Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Hello, this is North America Math Contest Go Go Go, and this week we are going to talk about, let me think. We are going to talk about the increasing and decreasing of function. Okay, so we know that it also a critical point. So we know that inflection point changes concavity, right? So with the inflection points and the critical points, we are able to get like how this will change, how the entire function will change by up or down. Let's see. Given a function, let me think. Okay, 2x to the power of 4 divided by 5x to the power of 3. Right? You're able to find where it increases and where it decreases. So for this type, we are going to find we'll do just critical points, right? Critical points, we use this way, we get the derivative. It's 0, right? So in this case, we just use this. And we get 8x is 15. So x is equals to 15 divided by 8. So it is a derivative. And the inflection point is, well, let me think. Right, okay, here is right. So the derivative, the second derivative is 24x squared minus 30x is 0. So 24x squared is equals to 30x, and 24x is equals to 30. So x is equals to 6 divided by 5. Critical points and inflection points. So we know we can just write all of them here, 1.2 and 1.875. Let's see. So now to do this, in this case, you only need to choose the number between any number between the following interval. The interval between 1.2 to 1.875, 1.875 to 3, and see whether they are positive or negative, so that you are able to see how it is changing. Okay. If you get negative, then it's going down. If you get positive, then it's going up. It all depends on how we do that. Okay, so we're getting the original function, which is, we get the original function, 16. Yes, getting the original function, and we are able to get the result. So we try 2, which 32 minus 30 is 2, so it's positive. Here is 1.5. Let me think. 322 divided by 4 is 1.5, approximately 10 minus, okay. So it's negative. And before 1, it is negative. So it follows down, down, up. So we can see that, how it is supposed to be changing. So the function is approximately looking like this at this point. So here is how this problem typically works. The way you solve it is to basically find the function, the critical points and all possible inflection points, and you just plug them and test the value and you can get how it is decreasing and increasing. Okay, so here, let's talk about LHopitals rule and what's that called? And what am I supposed to? Okay, and the velocity derivative, velocity and acceleration. So how it is going to work? Let's do velocity first. So velocity and acceleration. This is just a formula. Velocity is equal to the derivative of distance, and the acceleration is the derivative of velocity. Sorry, not the integral. The derivative, d derivative, v derivative. So we know that a is equal to d double derivative. So the given example, if the distance is calculated like this, calculate the velocity and the acceleration. Okay, so calculate the velocity at acceleration at x equals to 4. Velocity, using the derivative formula, we are able to get the acceleration is at 4, and you plug in 4, you get 16 times 26 minus 16, 16 times 26. And the acceleration is 54x minus 4. We get 212 is the acceleration. So here is how the velocity and acceleration works. It's just an easy thing. By the way, for the problem, if velocity is equal to 0, then it means just the particle does not change. It does not move anymore. Okay, so the next thing is LHopitals rule. Here, we redirect LHopitals. So what is the formula of LHopitals? Given x equals to y, right? Fx gx. If or infinite, then f g prime y is the final answer. So this is how LHopitals rule works. Let's give a specific example. Let me think. Okay, so we know that lim x to 6, right? X squared minus 2x squared plus 8 plus 6x. We are required to find the limit of it. How this is going to work is we first try whether it is equals to, okay, we set it to infinite, so it does much work. Infinite square minus 2 infinite cube. Okay, so both sides are work, right? Perfect. Let me change it so that the problem becomes more intricate. So works, right? It is equal to infinite divided by infinite. So the LHopitals rule actually works here. What we are going to do next is we are going to calculate the derivative of him, which is 2x 3x squared minus 2x 4x, right? This is the square, 3x squared plus 6, and you plug in infinite and you are able to get the answer. Plug in infinite, 3 infinite squared minus 4 infinite. It is not a good problem to apply here because you still need one more step of calculating it to see whether it actually works. Yes. So it is just basically how LHopitals rule is working. Briefly, last about related rates problem. This we are going to talk about on the next chapter. So this is the end of this week. I hope you have fun and enjoy. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!